Good morning. My name is Fabiana Gennari. I am a researcher from the National Commission of Atomic Energy from Argentina and also a researcher from the National Council of Scientific and Technological Research from Argentina. I will speak about metal hydride, different synthesis materials, and processes implementation. The most important point is how it's possible to obtain a metal hydride. It's by the reaction between a metal and hydrogen gas at a specific condition of pressure and temperature. In this way, metal hydride are formed in some specific condition, and in other condition it's possible to release the hydrogen in a reversible way. This is very important for the application, this reversibility. Then this solid is now a storage medium to transport and to storage the hydrogen, which two important characteristics or properties. One is a safe system and the second is an efficient system. Why is it a safe system? Because the solid, in particular the metal, has hydrogen bonded to the solid, and if this material is inside a tank, in case of the breakage, it's impossible to release the hydrogen suddenly. In other case, the second important property, the efficiency of the system, is because this type of materials, hydride materials, are solid with high storage capacity and per unit of volume and weight. In this way, we have a solid with a high density of hydrogen in a small volume and very light. Which are the main synthesis methods to obtain a hydride? One is by mechanical milling in both conditions, or an inert atmosphere or in a reactive atmosphere. In the first case, inert atmosphere, for example, two metals like nickel and magnesium are put inside a milling chamber. By the movement of the balls, which impact and friction with the material, is possible to obtain and allow, for example, magnesium-nickel intermetallic, and after this, the powder, very activated with defect in the surface and with a small nanometric crystallite size, is put inside of the reactor at a specific temperature and pressure condition under hydrogen atmosphere. Finally, it's possible to obtain the metal hydride. In the second case, the reactive atmosphere is known as mechanical milling, reactive mechanical milling. In, for example, hydrogen, is possible to allow the nickel with magnesium and simultaneously form the new hydride, a complex hydride, during the milling. Our interest is to use a metal hydride for carbon dioxide conversion. Why? Because this metal hydride has two functions. It's a dual material. One of these functions is the source of hydrogen, and the other is a catalyst. Also, is able to provide the catalyst to allow the transformation of carbon dioxide in a desired product, like methane or other fuels, like the mix of methane with hydrogen. How is possible to do this? For example, by a thermochemical process using a reactor, batch reactor, in which the hydride is placed inside the reactor, and using the temperature and at a specific pressure, the transformation of carbon dioxide occurs. Other possibility is use reactor under flow condition, using also the temperature as the activation of the process. And the second type of the reaction are the mechanochemical processing, in which the hydride is placed inside of the milling chamber together with the carbon dioxide pressure. This system is closed, and at room temperature it's possible to transform the carbon dioxide to a specific product like methane. All these processes depend of different variables or parameters like the nature of the hydride, the microstructure of the materials, the hydrogen and carbon dioxide ratio, the nature of the catalyst, and the temperature and time of the reaction. Controlling this variable is possible to find the optimal condition to favor the conversion of carbon dioxide and achieve high selectivity to the desired product, mainly natural gas and mix of the blends of methane with hydrogen.